factoring. And I provided a handout, and it's just some factoring problems that we're going to go through. This golden piece of paper, specifically referred to as golden, because it does help you factor anything, any kind of problem that you're given. So you just want to make sure that you keep this handy as you're going through your homework or anything like that. I'm sure your teacher won't allow you to use it on a test or anything like that. But hopefully you get the process down enough before the test where this is really helpful. And that's what we're going to be using today. I'll show you how to use this for every single type of problem. Because the thing about factoring is it's very important. It's a skill that you use in 310, 320. If you do go to college algebra or any higher math, you will use it there. So it's one of those skills that carries over to any math class that you go into. Now the thing about factoring also is, when you get to a test, it's going to say factor. It's not going to say, this is a difference of squares. Factor is a difference of squares. This is factoring by grouping. Factoring by grouping. It'll just say factor, so we have to know how to factor each type of problem. So the first one says we have x squared minus 4x minus 21. So I'm going to go to my factoring flowchart, a little yellow piece of paper, and I'm going to start where it says start, right? It's a good place to start. So the start button. And follow the arrow. So the first question we ask ourselves is there a greatest common factor? We look at those three terms. Is there a greatest common factor for this problem? No. Is there anything common to all three pieces? No. We have a couple x's in the first two, but no x's on the last one. There's nothing common to all three pieces. So no, we follow the no arrow. How many terms are there?
Three.
No. Three terms. Okay, so we're going to follow the path that says 3. Then the next question we ask is it a perfect square trinomial? We'll get to that, to some of them, but what you look for are the back ends perfect squares. X squared is, but is 21 a perfect square?
No.
No. So we're going to follow the next path that says, is the leading coefficient 1? What's the leading coefficient? What does that word mean? The number in front of the x squared term. Is that number 1?
Yes.
Yes. So it says simple factoring. Determine the factors of the last term that sum to the middle term. So what we're asking ourselves is what multiplies to give me a negative 21, the last term, and also adds up to negative 4. All right. So what are some numbers that multiply to give us 21?
7 and 3.
7 and 3. And there's also 1 and 21, right? Well, which pairing is really going to work here?
1 and
21.
7 and 3.
7 and 3. And then how do we have to order the signs in order for it to work? Negative 7. Right? Because a negative 7 times 3 is negative 21. And a negative 7 plus 3 is negative 4. It works for both situations. That's what we're looking for. This was a simple factoring, so we can go straight to our parentheses and say, well, it's going to be x minus 7 and x plus 3, and we're done. That's all we have to do there. So we good on that one? Take it slowly. Taking it slowly. All right, so let's go to the next one. Does everyone have this one copied out? Did you? Y squared minus 21y plus 9. So, I'll go back to this. Start and say, is there a greatest common factor?
Yes.
Is there something common to all three? Yes. What is that greatest common factor? There's a 3 common to all 3 pieces. If we factor that out, what are we left with?
Y squared.
Y squared.
27y. No.
7.
7, right? And is it positive or negative?
Negative.
Negative, same sign.
And plus
3. Right. Well, we did that. We took out the greatest common factor, so that arrow is going to bring us back to how many terms are left? 3 terms. Is it a perfect square trinomial?
No.
That is, but that isn't. So no. Leading coefficient is 1.
Yes.
Yes, that 3 is on the outside, so we're just worried about what's on the inside. So let's try simple factoring and see if this works. So we're saying, well, is there anything that multiplies to give us a positive 3 that also adds to give us negative 7? What are the only two numbers that give us 3?
1 and 2.
Is there any way we can order the signs or anything like that
Yeah.
to give us negative 7?
No.
So this is as far as we can go.
Prime.
Now, why can't we say prime?
Oh, because
Because
it's
you
three
made
in
a
front.
factor.
We did factor it. It was just that greatest common factor, but we did do some factoring on it. So this would just be your answer.
What's the definition of prime?
It's up there in the big bold box in the upper right-hand corner.
I just wanted to hear you say.
Okay, I'll be more than happy to read that for you. A polynomial is prime, not factorable, if and only if there is no greatest common factor, and none of the processes for factoring can break the polynomial apart. So we did have a greatest common factor, so we did break it apart a little bit. We just couldn't go any further. Okay. Everybody good on that one? All right, 6x minus 9y plus 8x, 8ax minus 12ay. All right, so once again, follow the
Did you break
factor.
this up, rearrange it?
We could, but we don't have to.
Just do it.
All right, so start.
Just separate for it.
Is there a greatest common factor?
No.
There's nothing common to all 4 pieces. So no. How many terms are there? 4. So we follow the arrow from 4 over, and it says factor by grouping. What grouping means is you look at the first, you look at the 2 pieces separately. Now we may have to rearrange them, but for the most part, go with the 2 that they give you and see if you can't factor from there. Is there a greatest common factor out of the first 2 pieces?
Yes.
3. And what are they going to leave you with?
X minus
2x,
negative 3y.
Right. Remember, it has to multiply back to what you had. 3 times 2 is 6. 3 times negative 3, negative 9. Always bring down that sign, whatever it is, plus. What's common to 8ax and minus 12ay? 4, and what else?
A.
A, there's an A common there too. So, if I take 4a out of that 8ax,
2x.
2x, and then minus,
3y.
right, 4a times 3y. What do I notice about my parentheses? For grouping to work, do they always have to be the same? Yes. Yeah, for grouping to work. So if you're coming up with something different in these parentheses, go back and check it. Something may be wrong with the sign, or you may need to rearrange it. So my 2 factors are going to be the common factor, 2x minus 3y.
Plus 3 plus 4.
Right. And then my other factor is just going to be my coefficient, 3 plus 4a.
Then it doesn't matter what goes first, right?
Nope. You can put this one first and this one second. Does not matter.
But they must be in parentheses.
They must be in the parentheses. The reason why it doesn't matter the order, think about multiplication in general, because that's what we're doing here, right? We're taking this times that. Think about multiplication. Is 6 times 3 the same thing as 3 times 6? That's why the order doesn't matter. So when you're factoring, just make sure you have the same information, but it does not matter the order of the parentheses. Okay. Everybody good on that one?
Where did you get the 2x?
This 2x?
No, yeah.
4 times 2 is 8, and then the 8x. So I have to figure out what times 4a and we're moving back to 8ax. So 4 times 2 is 8, and then 8 times x is 8x. Okay?
Sorry, I'm going back to number 1 real quick,
Mhm.
just real quick. The answer was x minus 7 and x minus 3. Is it the x by itself because of from by the x and x is 4?
Because x times x is x squared. That's the only way to get x squared is x times x. All right. Did everybody get on 3? All right. Now for a good one.
You ought to create a workshop called Math Game Day.
Only now. All right, 3x squared minus 13x minus 10. So, I know, I'm kind of beating a dead horse with this whole factoring thing, but it does work. So, greatest common factor? No, there's nothing common to all three. So, how many terms? 3. Is it a perfect square trinomial? And we're going to get to some of those where you can recognize them. Basically, look at our front and back ends first.
No.
No, 3 is not a perfect square number. So is the leading coefficient 1?
No, it's not.
Leading coefficient is 3, something other than 1. So we have to go to a different method than we use for number 1. Right? So we have to use trial and error, grouping. Different instructors call it different things. They all boil down to basically the same factoring method. So what we're going to do is we're going to take our leading coefficient here, and we're going to multiply it. 3 times negative 10. Okay, so what we're looking for now are two numbers that multiply to give you negative 30, and then add up to the middle term of negative 13.
Negative 15 plus 2.
Okay. So, once again, sometimes we need to write the numbers out. So that's all the numbers with possibility to give us 30. The only one that's going to work, somebody did say that, was 2 and 15. That's the only possibility, right?
Yep.
Why couldn't we use 3 and 10?
Because one's negative and one's positive.
Exactly. There's no way you get 3 and 10 to give you a difference of 13.
They were both negative.
Exactly. They have to both be negative. And that just wouldn't work. All right. So in number 1, we could go straight to our parentheses. Right? We got our numbers, we could go straight to our parentheses. Using this process, you cannot. You have to rewrite your expression here for something different. So what I've done is I've split my middle term into the two pieces I said should work. Negative 15 and a positive 2. Notice the front and the back did not change at all. It's still 3x squared and it's still minus 10. The only thing that changed was the middle. I broke it up into negative 15x and positive 2x using the numbers that we said should work. Now I have 4 terms. I'm going to factor with 4 terms.
Perfect last one.
Yep. And same we did number 2. What is common to the first 2 pieces? 3. 3 and then x. Right, both of them have at least one x available. So 3x times what brings you back to 3x squared?
X minus 5.
X, and then 3x times minus 5 will bring you back to the negative 15x. This is a plus. What can I factor out of 2x minus 10? 2. 2 is the only thing common to that pairing. And what's that going to leave me?
X minus 5.
2 times x is 2x. 2 times negative 5 is negative 10. All my parentheses the same?
Yes.
Yes, that's a good thing. Because now I can write it as my common factor, x minus 5. And then my other factor will be my coefficients. 3x plus 2. And we're done. Now, if I'm unsure that's correct, how could I check myself? I can fill it out. I can multiply back out, and if I come back to the original problem, I know I done that correctly. So if you're ever unsure, check yourself. Everybody good on that one? Yeah, it's kind of a longer process, but it always works. Okay.
Okay, so question.
Yes,
So if you have if your coefficient, is more than one, that's when you multiply. the
yes.
First
You
term.
always want to make sure that you want to take out a greatest common factor first if you can. But after you do that, if there's still something greater than 1 here, yes.
That's if you don't have a common factor.
Yep.
That's the only time you do that? The only
Possible.
time you multiply the first and last numbers?
Right.
Too late.
All right. Everybody good on that? Good to go to number 5? Is there a greatest common factor?
No.
How many terms? 3. Is it a perfect square trinomial? No. So is the leading coefficient 1? No. So now we're back to what we were doing in the last problem. So 2 times 15 is 30. So we're looking for 2 numbers that multiply to give us a positive 30 that add up to 1.
What?
5 and 6.
Wait, wait.
5 and 6.
15 and 15.
Wait a minute.
Actually, that's fine.
Oh, that's right. See, 1 because of X.
Right, that's
I
our
want
1x.
X. Okay.
Yeah, a lot of people are saying 6 and maybe -5, right?
Yes.
But 6 times -5 is what?
Negative 30.
Negative.
Negative 30.
6 times 5.
15 plus 15.
Negative 6 plus 5.
That would give us a negative 20. That would-
Negative 6.
We're running into some problems here, right? None of these are working.
Jennifer, we have a problem. Oh my God, that was the worst of my life I ever seen.
Change something.
Negative 6 times
That would give me 30, but what does that add up to?
30.
What? Anybody come up with anything that works?
30.
-1 and negative 30.
That would be
No,
negative 30.
no, that's not
6 minus 5.
6 times -5 is negative 30. though.
Plus 6 and -5. I mean, plus,
I'm hearing a good answer.
and,
Somebody said not factorable.
oh,
Was it
There's
five?
Not factor.
It's not factorable.
Yeah, that's
There's no 2 numbers that we can come up with that will work.
So does that make that prime?
That makes this prime. Right? Because the only way we come up with a positive 30 is if both of our signs are the same. Well, if you had 2 numbers whose signs are the same, the number's just going to get bigger. There's no way to get to 1. That's just not going to work. So that one's going to be prime. So just change this. That's it. Easiest thing.
so right now, we wasn't looking for, would it give us a positive 1, we was looking for, would it give us a positive 30?
What
2
will
numbers gotta give us positive
Well, the
30.
number will multiply to give us a positive 30 and add up to a positive 1. And no 2 numbers will give us that situation.
And you have the positive 1 because of the X in the middle, right?
Yep, that's a 1x. Yep. All right. Good on that one? Okay, sort of. All right. Well, we got 11 more, so hopefully we'll get them down. All right, 6 is a little different because we've got fewer terms here, but we're still going to follow the same patterns for solving.
Perfect square thing, right?
Yeah, but you got to be careful with this one. I do see perfect squares, but what's my first step?
Greatest common
Greatest common factor.
What
What would be 4? So what does that leave me with?
4x squared and 1 minus 1.
Minus 1.
Yep. And then I say, well, how many terms do I have? 2. All right, So that leads me to one of these four possibilities. Ignore the sum and difference of cubes. You won't really need those. Just focus on the squares one for the time being. We didn't keep that around because some of the instructors do cover those. 4x squared minus 1. Do we have two perfect squares there?
Yes.
Mm-hmm.
4x squared, that's a perfect square.
No,
Yes.
it is.
no, negative one is in the
One times
times
one
one
is
is
one. It's squared.
Where's 90?
So we have a difference of perfect squares. So we're going to use that difference of squares formula. The difference of squares formula says a squared minus b squared
Equals A minus B. A plus B squared.
All right, so a lot of formulas, some letters. What does it really mean? Well, what it means is we're going to write two sets of parentheses. You take the square root of the first part. What's the square root of 4x squared?
2x.
You put that here. What's the square root of 1?
1.
You put that at the back end. One's plus, one's minus. And you're done with the problem.
Does it matter which one goes first, the plus or the minus?
Nope.
Okay.
Yeah, just like we were talking about the order, it's multiplication, so it doesn't matter what the order is. Just as long as one has 2x and 1, and then one's plus and one's minus. Makes sense? There's mine, right? Can I erase this one?
Is the next workshop next week the same as that one?
How do I know when to do that? Did I get the squares, make sure that there's difference of squares?
Yes. Well, I had two perfect squares separated by a minus sign. So that tells me the difference of squares.
Okay.
7. 16x squared plus 56x plus 49. All right, so let's follow our pattern again. Is there a greatest common factor?
No.
No, I mean, 16 and 56 might be 4, but 49, we run out of what's there. So no greatest common factor. How many terms are there?
3.
3. Perfect square trinomial?
Yes.
Possible.
Mm-hmm.
Why do I say possible? The front and back ends are perfect squares.
But they have to
Yeah, we have
But
to
this-
the middle.
We have to do a check on it to make sure. Now the thing is, I'm hoping it's a perfect square trinomial because I don't want to multiply 16 times 49 and come up with 56. So let's check to see if it's a perfect square trinomial. What you do is you take the front and back ends and take the square root of both of those. So what is the square root of 16x squared?
4x.
4x. What is the square root of 49? 7. If I multiply those, what do I get?
28.
28x. And if I double this, what do I end up with? This piece has to match your middle. Does it?
Yes.
Yes. That's the check to see if it's a perfect square trinomial.
Where does the times 2 come in?
Because you have two factors. Right? Factoring involves one pair of parentheses. So since we have two factors, we have to do it twice. So does the piece that we end up, does it match our middle piece?
Yes.
Yes. So we can use this perfect square trinomial shortcut. My answer is going to be the square root of 4x, or square root of 16x squared, which is 4x. What's the square root of 49?
Plus 7.
Use the sign in the middle and square it, and you are done. Because 4x plus 7 squared really means this, correct?
Yes.
Right? And if I FOIL this out, I am going to end up with this. But if it's a perfect square trinomial, you can use this shortcut. You just have to show that it's going to check. You have to make sure that it is that way. Because we're going to come across one down that won't. I'll show you how to do that one. first step. Is there a greatest common factor?
No.
No, we have, looks like 4 pieces here. There's nothing common to all 4. How many pieces are there? How many terms are there?
4.
4, so that tells us we should factor by grouping. We look at that first pairing. Is there something common to both of them?
X squared.
X squared. What's that going to leave you with?
Y squared plus 16.
Yep. Just the 16 though. We took that X squared out. That X squared's gone. This second piece leads with a negative, so we have to factor out a negative. What's common to 4 and 64? 4. 4 does go into 64. Yep. Well, I hope so, because if not, I'm going to end up with the same parentheses here. So I factor a 4 out. What am I left with for this first piece? Y squared. And because I factored a negative out, that means I have to change the sign. Because a negative times a positive is the only way I'm going to come back to a negative there. So 4 times what gives me 64?
16.
Yeah, I'm hoping it's 16. And it is. Because now my parentheses are the same. So how can I write my 2 factors?
Y squared plus 16.
Y squared plus
16
And X squared minus 4.
plus negative minus 4.
Minus 4. Am I done?
No.
Why am I not done?
Because you still got Y squared, and you can pull out Y.
You got the X squared down at the bottom.
Every
Yeah,
Four
squared.
times
Let's take a look at this one. I have 2 pieces here, right? So let's see. What are my possibilities for factoring if I only have 2 terms? It looks like I have a sum of squares and a difference of squares. Because we're going to stay away from the cubes. Well, is this a sum of squares or a difference of squares? It's a sum, right? Sum is the plus. What does it say about the sum of squares? It says it right there.
A squared plus B squared equals not.
Not factorable. There's no way to break that one down.
So just stay there.
What's the difference?
This one stays the same. It's the other one that we can do something with. Because that one is a difference of squares. Right? We have a perfect square and a perfect square separated by a minus sign.
X minus 2, X plus 2.
Exactly. We're going to treat it like we did number 6. Right? Take the square root of x squared, and I get x and x. The square root of 4 is 2 and 2. Difference of squares means different signs. And this will be completely factored.
I have no idea why you didn't factor down 16.
Okay? This one?
Yes.
All right. What are the only 2 possible ways to get a positive 16?
They have to both be positive.
They would both have to be the same sign. That are the only 2 possibilities. So if I boil it out, what am I going to end up with?
You're gonna end up Y squared.
Positive 16.
All right? First, outer, inner, last. And if I boil this one out, what is
She
this?
wanted to put the trinomial instead of the binary.
Exactly.
Ooh, listen to me, that sounds so smart.
If I add my terms there, this is what I end up with. Does that match what I have?
Yeah.
Right. So there's only 2 possibilities of getting a positive 16. And if I try to break it apart, my 2 pieces fail to give me that. So that's why that's not factorable. There's no way that breaks apart.
But it's not factored because it's positive.
Right.
Right?
If you ever see 2 perfect squares with a plus sign between them, it's prime. Move on.
Really?
Can't do anything with it. And we'll run into that here in a couple spots. Hey, look at that, number 9. All right, is everybody good on this one? At least got it copied down to a point. This leads in perfectly to number 9. Number 9 says we have 4x squared plus 9. So is there a greatest common factor? No. How many terms are there? 2. So it's either a sum of squares or difference of squares.
Sum of squares.
It's a sum, it's a plus sign, and the sum of squares is non-factorable.
That stays like that.
So you just say, well, I can't do anything with that. That's prime. That's the easiest one to test. If you see 2 perfect squares with a plus sign, prime, circle it, you're done. Go to the next problem. No, it's easy 4 or 5 points. There's no way that's going to break down. Easy enough, right? Now, if I had a minus sign, I could. But if it's plus, move on. Ready for number 10? Why not? Let's give it to me. All right, y to the 4th minus 4y squared. It's not like a repeating record here, but greatest common factor.
Y squared.
Y squared, right? We have at least 2 y's. So let's take that out. What is that going to leave me?
Y squared minus 4.
Y squared, right? Y squared times y squared is y to the 4th. And then if I take the y squared off of 4y squared, just off of 4. So what I'm left with has 2 terms. So it's either a sum or a difference of squares. The difference, there's a minus sign there. So is that the one I can break apart?
Yes.
Yes. What's the square root of y squared?
1.
So y, what's the square root of 4? 2. 2 and 2. One's plus, one's minus. Difference of squares means different signs. Oh, this one, yeah. Yes. Question?
Yeah, why did you do 2 parentheses?
The difference of squares. So we've ran into the almost identical problem.
Okay, you perfect squares like that.
Right.
Okay.
So
Okay.
and because we have different signs, we have to set up 2 different
signs.
parentheses.
Yeah, I got
Were you asking something, or were you answering?
The 4 turns into 2 because
We're taking the square root.
square root.
Yeah, the square root of 4. Because 4 is considered a perfect square because 2 times 2 is 4. 11. All right, everybody good on number 10? All right, here we have x squared minus 18xy minus 40y squared. So, start over with that process again. Is there a greatest common factor? No. No, it looks like there might be, but we only have x's in the first 2 and y's in the second 2, so we can't do anything there. How many terms are there? 3. Is it a perfect square trinomial? No, we're almost there here, but 40 isn't a perfect square, so we can't go that route. Is our leading coefficient 1?
Yes.
Yes. So we're back to simple factoring. We're just looking for the numbers that multiply to give us a negative 40.
Negative 20 and 2.
And that add up to negative 18. Somebody did say negative 20 and 2, and why will that work?
Negative sign's right and the number's right.
Okay. So a negative 20 times 2, does everybody agree that gives me negative 3?
Yes.
And negative 20 plus 2 adds up to negative 18. So those are our two numbers. This is the one we can go straight to our parentheses with. This is the simple factor. We don't have to split it up like we did the other one, because our leading coefficient was 1. So, what's the only way we can get x squared?
X over
Check.
there.
What were the two numbers that we said would work?
22.
Plus 2.
Now, how do I deal with the y?
Add it on to the end of 2.
You add it on to the end of the
One
numbers.
each, one in
there-
each parentheses.
There's the only way we can get y squared is like the same way we can only get x squared. It has to be attached here at the end of the number. And that takes care of it. We're done with that problem. Any questions, Ray?
I got a question.
Uh-huh.
How did you get so darn smart?
I don't know. I was born in a lab somewhere. in the 60s. Yeah, exactly. That's exactly what happened. All right, so are we good on number 11?
Yes.
Is there a greatest common factor?
No.
How many terms are there? Is it a perfect square trinomial?
Yes.
No, leading coefficient
X
is
and
1.
X and 3 and 3.
Yeah, but remember
That's a
that
good way to recognize.
3 times 3 is
Right
9,
now.
though. Yeah.
Yeah.
Like a
That's
perfect
two.
squares, you have to know, your perfect squares are like 4, 9, 16, 25. It has to be a number. Yeah, so like 3 times 3 is 9, 2 times 2 is 4. There's no way we can get two numbers to multiply to give us 6. So is our leading coefficient 1?
Yes.
Yes. So this is the one where we can go straight to our parentheses. We're looking for two numbers that multiply to give you 6 and add up to a negative 5. Somebody said a negative 6 and 1?
No, it's negative 3 and negative 2.
Negative 6 plus 1 adds up to a negative 5. I agree with that. But negative 6 times 1 is a negative 6. So be careful there. I put this one on here because I see people mess this one up all the time. So this one's a little tricky. Someone did say negative 2 and negative 3.
Does it matter which order you put it in?
Nope. Does negative 2 times negative 3 give you positive 6?
Yes.
Negative 2 and negative 3 add up to negative 5? Yes. It works for both of them. We can go straight to our parentheses here. It's the simple factor.
Isn't it a simpler way you could, give you the numbers, the negatives? You can look at the end number and see that you will need.
Yeah,
both of
and
them
it does
to be
follow a
negative.
certain pattern here. The only way we can get a positive 6 is that the two signs have to be the same, right? So they have to be positive or negative. And then because our middle term is negative, that tells us they both have to be negative. So that's another way of looking at it as well. Yep. Very true. All right, we good on number 12?
Yeah.
All right, please. The next few look a little interesting. By interesting, I mean different. 12, good? All right. Greatest common factor.
Yes.
Yes, there is. Is it 2? Anybody, can anybody think of anything higher? It's okay if you can't. I agree with 2. Close on 10, but this doesn't end at 0.
6?
I'm thinking 2 is a pretty good guess. I'm just seeing if anybody else can think of anything going higher. No, 2's it. So if we take the 2 out,
Will 12 work or no?
no, because 12 can't go into 50.
Oh, okay.
Yeah, I don't think it goes into the 162. No. All right, so
Minus 90x1.
it's y, right? How many terms do I have left?
3.
3. And I'm hoping this is a perfect square trinomial.
It is.
It is. Sure, front and back. Well, it possibly is. We still have to do the check. So, are these perfect squares?
5x and 9.
5x and
9.
9y. Okay, so let's go over here to do our check to see if it is a perfect square trinomial. So we've got 25x squared, and we have 81y squared. Someone said the perfect square of 25x squared is 5x. 9y. If we multiply those together, what do I get?
45x.
45xy. Because I'm dealing with two factors, right? Two sets of parentheses. I have to double that. If I double 45xy, yeah. Someone said 984. That's good. 98y. Does this match my middle term?
Yes.
Yes. So it is a perfect square trinomial. So we can use that shortcut we used a few problems back. We're just going to say, well, the square root of 25x squared is 5x. The square root of 81y squared is 9y. Use the sign in the middle. Squared. And don't forget about, don't forget about the k you dropped out, right? There's your answer. Now, there's nothing wrong with going 25 times 81 and working it out that way.
See,
I
I
don't
wanna
want to do that. I have better things to do with my time.
See, I want to solve that. I want
Can't
to
just go-
distribute. And actually want to distribute.
Yeah, but if you distribute, you're going to come back to here. If you're ever multiplying when you're factoring, you're doing something wrong. Because factoring is about breaking apart, not putting back together. Okay. It's the opposite of multiplication. We good on 13?
Yes.
14. Let's see. Is there a greatest common factor?
3x.
4? So 3 can go to all three of those. And x to the fourth, right? They all have at least x to the fourth. So let's take that out.
Oh, because you have to use the smallest power?
Yes, and they all three involve x here. And so there's an x common, how many? At least 4. So if I take 3x to the fourth away from 3x to 6, x squared.
Wouldn't that be 2x squared?
Well, 3 times 1 would bring back to 3. Now we're moving to the 6. 3 times what gives me 6?
Oh, okay, okay.
2x. And then the last one, 3 times what gives me negative 45? 15, and I've already taken that x to the fourth out, so there's nothing left. I got 3 terms left. Is it going to be one of those simple factoring ones, or is it the one where you have to do the front and back? What's that number in front of x squared? 1. So we just did our simple factoring now. What times, what two numbers give us negative 15?
Negative 3 and negative 5.
And add up to a positive 2. All right, so we said negative 3 and negative 5.
Oh, no. It's going to be positive 5 and negative 3.
All right, does everybody agree with that?
Yes.
So negative 3 times 5 is negative 15. Negative 3 plus 5 is 2. So negative 3 and 5 are the two numbers. Can I go straight to my parentheses here? Yes, it was a simple factoring one.
Yep.
The one where we didn't have to multiply the front times the back. So it's just going to be x minus 3 and x plus 5. And you are done. I had to come up with two numbers that multiply to give me negative 15, and add up to positive 2.
Oh, okay.
So the two numbers that would work are negative 3 and 5.
Oh, okay.
So those are the two numbers I'm going to use for my factors there.
Okay.
Check them right there. That -3 is first, in that first part, as the answer is that first.
I could have written it as plus 5 and minus 3.
Either way.
The order does not matter. As
But I
long
mean,
as-
I guess, I know that order don't matter, but I'm just saying, like, those are the numbers you use.
Yes. Any other questions on 14?
It doesn't matter what order you put it in at the bottom, right?
No,
But
as
it
long as
does
the negative is
matter-
on the 3
Right.
and the positive is on the 5. But you could have written it as a positive 5 here
That
and
doesn't
a
matter.
negative 3 here. It doesn't matter.
So the operator in the middle always goes with the bigger number? On the
Well,
original
that's the only
equation?
way we could have come up with a positive 2.
Yeah, but I mean, even if it was, if the end was different than that, and it was negative 5 plus positive 3, gives you negative x2, the negative sign would still go with the bigger number. And is that always true?
That's not true.
Negative 5 plus positive 3 is negative 2. If that
Right.
was-
So this would have had to been a negative 2.
Right, that's what I'm saying.
Right, so this,
So if that was a
your signs are
negative in
different.
the beginning, it would still go with the 5, because the 5 is the bigger number.
Well, there's always going to be an operator on a number.
Right, but the bigger of the two factors of 15 will always go with that operator. Yes?
Which operator?
The plus.
Okay.
The plus in the original equation.
Right.
When you factor out 15 to negative 3 plus 5 gives you positive 2.
If your signs are different, this,
Your plus
this
on the
operator,
bottom has to go with the bigger number.
if your signs are different, this operator will always be in the bigger number.
Right, that's what I'm saying.
Okay.
Okay.
Yes.
I got you now.
That's why they do the form and everything, you know which one is the outer, which one is the inner.
We're speaking the same language, just different.
Just
numbers.
different signs.
All right. Good on 14?
Yes.
All right. All right, 15 is a little tricky. Gotta check it. Is there a greatest common factor?
No.
How many terms is there?
3.
Is there a perfect square term?
Yes.
Yeah.
Possible.
Possibly, yeah, we know.
Let's check it. So we're looking at our front and back ends, which are perfect squares. So 4x squared, what's the square root of 4x squared?
2x.
What's the square root of 9?
3.
So 2x times 3?
6x.
6x, and if I double that,
12x.
does that match my middle
Yeah.
term?
No.
No. So it's not a perfect square trinomial. It has to follow, it has to do that check. Even though our front and back ends are perfect squares, does not necessarily mean it's a perfect square trinomial. So it's not a perfect square trinomial. Is the leading coefficient 1?
No.
So we have to do that right way. The front times the back. So we have to do 4 times 9, 36. So we're looking for two numbers that multiply to give us a 36, positive 36, that add up to a negative 15. Any ideas there?
4 and
2 to 13.
13.
Oh.
12 and 3? 12.
I'm thinking 12 and 3. Now what would the signs in those have to be?
Do have to.
In order to multiply to give you a positive, but add up to a negative.
Right. Negative times a negative.
Negative times a negative. They both have to be negative. All right. Negative 12 times negative 3 is a positive 36. Negative 12 plus a negative 3 adds together to give you negative 15. Right? Okay. So we're going to have to rewrite our expression here. This is where we have to split the middle term. We can't go straight to our parentheses. That process was different. We had to multiply the front and back here. So we're going to rewrite it as 4x squared. The two numbers we said would work, negative 12.
Minus 3x.
All right, so Notice once again, the front and the back ends did not change. There's just the middle that got split into those two pieces. I have 4 terms, so I'm going to factor by grouping for x. What's common to the first 2 pieces?
4.
4, and then x is common. And what's that going to leave me? X minus 3. This last grouping begins with a negative number, so we have to factor out a negative number. So what's common to 3x and 9? We're going to do 3. What's that leave me?
X plus 3.
X.
Minus 3.
I factored out a negative. Yep, so I have to change that sign to a negative. That's going to have to work too, because my parentheses have to be the same there. So what are my 2 factors?
X minus 3.
That's the common one. Or
4x minus 3.
you got it, 4x minus 3. And that is our factor 4. So that one's a little tricky, right? It looked like it might be a perfect square trinomial, but you have to do the check on it to make sure. That's why that's important. Because it would have been very easy to try that shortcut without checking it, and it would have been incorrect. So
Can
be
you
careful.
always tell if that's going to be a perfect square trinomial if the middle number is also,
Odd?
yeah.
Not all the time.
I mean, like if the middle number was 25.
More than likely not. But the problems that you're going to see that is true. If the middle number is odd, it's not going to be a perfect square trinomial. Because the only way you can get an odd number, multiplying anything by 2 is going to give you an even number. So that's another check.
Okay.
Yeah. The middle number is always going to be odd. Or, sorry. All right, we good on that one? All right, got one more. Then we got time for it. Thank you very much. Factor? Yeah, you can be the same way as we did. 2x squared. Is there a greatest common factor?
No.
How many terms are there?
3.
Is it a perfect square trinomial?
No.
No. Yeah, the answers are just flying out. Good. All right. So front back ends aren't perfect squares. Is the leading coefficient 1?
No.
No. So that leads us all the way to the end of our path.
Yep.
So we trial and error or grouping, whichever method you're more comfortable with. But the method that we've been using.
This is unfactorable.
Really? 2 times negative 20.
Negative 40.
Negative 40. So we're looking for 2 numbers that multiply to give us
Never
a
mind,
negative 40.
I'm wrong. I didn't remember that step.
Negative 8 plus 5.
Yeah.
I do agree with 85, and somebody was calling out the signs here. Which one would have to be negative?
8.
8, right?
Always the very one.
Right. That's the only way we get a negative 3 out of that, and a negative 40. That's the only possibility. So remember, this is not the one where we can go straight to our parentheses, because our leading coefficient wasn't 1. We have to rewrite it. 2x squared minus 8x plus 5x minus 20. 4 terms means
Grouping.
Factor by
grouping. Got it. What can I factor out of those first 2?
2x.
2x. Perfect.
X minus 4.
X minus 4. Right. I'm leading with a positive, so I have to factor out a positive 5. What's that leaving with? 4. Yep, it has to be, right?
Yep.
Or those parentheses to match. So my 2 factors are?
X minus 4. And X plus 5.
And I'm done, right?
Yes.
That's it. All right, I hope it helped, guys. The factoring workshop next week will be the same exact one, so if you want to come back and get some more practice, but just let you know it will be the same problem.